What's going on, guys? Today I'm going to be teaching you how to find the Lewis structure of C2H2. And this video is for those who are curious, the wonders of the students in the world. And I know what you're thinking. Joaquin, this is basic chemistry. We all know this. This is baby shit. And to that I say, well, if you were so highly educated in chemistry, of course you would know this. Of course this is nothing to you. But there are many people out in this world who don't give a shit about chemistry. And that's okay. And that's why I'm making this video. So before I get critiqued by, let's say, someone who gets pegged by his girlfriend and maybe goes by the name E-Peg, or before I get critiqued by someone with albino eyebrows and goes by the name of Chummy, not saying that's true or whatever, I'm just saying, I would just like to let it be known that this is for those who may be curious and want to dive deeper into the world of chemistry. And we got to start somewhere, right? So let's get into it. Lewis structure. We want to find the Lewis structure, the 2D dimension of C2H2. Now, the first thing we want to do is figure out, okay, how many valence electrons does each element have? So let's start with carbon. We know that carbon on its own has 4 valence electrons, but because there's 2, we're going to times that by 2, making that a total of 8 valence electrons. Now, hydrogen has 1 valence electron, but because there's 2, good job, that's going to make it 2 valence electrons. Now, if we add that up, that totals out to 10 valence electrons. And it's important to remember when you're doing Lewis structure, a lot of students get confused on which one do I put in the center? Do I do CHH? Do I do HCC? You always want to put the element with the lowest electric negativity in the center. And just for rule of thumb, hydrogen never goes. Just know, ignore the bullshit I just said. Just know hydrogen never goes in the center. It is never HCC. Don't ever do that dumbass shit, okay? So now that we know that, we're going to put carbon, carbon, hydrogen, hydrogen. Boom, right? Okay, so we want to draw the 2D dimensional structure for C2H2. What we're going to do, like we mentioned before, we have 10 valence electrons. So we have to use 10 valence electrons and also meet what's called octets rule. Each element has a max shell of electrons that they have to fulfill. So because carbon has 4 valence electrons, it needs 4 more to fulfill octets rule, which is a full shell of 8 electrons. So we're going to start by making what's called single bonds. That's a single bond right there. That's a single bond right there. And that's a single bond right there. Hydrogen is fulfilled because it only needs 1 shell. It only needs 1 bond to be fulfilled. It's chilling on its own. So don't worry. Once you connect this to this, you're big chilling. Don't even think twice about it. Boom, you got that. But you have to remember, each bond represents a certain amount of valence electrons. 1 bond equals 2 valence electrons. A double bond equals 4 valence electrons. And a triple bond equals 6 valence electrons. Just keeping that in mind. So far we have done 2, 4, 6. And our total was 10. So we subtract 6. That's 4. Right? Because 9, 8, 7, 6, 5, 4. So now that we have 4 valence electrons remaining, what we want to do is put those lone pairs of valence electrons on the outside of the carbon, not the hydrogen, because the hydrogen only needs 1 valence electron. So don't be putting your grubby fingers all over the hydrogen because it's cool, it's chilling. Right? You wouldn't go up to a girl and ask her for her number after she slapped you in the face and told her to get the fuck away from me, right? So we have 4 valence electrons, so let's distribute this accordingly. We have 1 lone pair, that's 2 valence electrons, and we have another lone pair, that's 4 valence electrons. So let's see, does this fulfill octets rule for carbon? Because we know the hydrogen is fulfilled because it's all it needs is 1 bond, so that's good. 2, 4, 6. Nope. You need 8. So that is not fulfilled. So what can we do? What the fuck do we do? We used all our valence electrons. We're cooked. There's nothing we can do. See, that's what an unskilled person who doesn't know much about chemistry would think, and that's okay. Someone like EPEG or someone with albino eyebrows would give you shit for that. But I'm not going to, right? So what we're going to do is we're going to make a double bond. And let's see what that happens. So we draw our hydrogen. We draw our single bond to the carbon. We use one individual valence electron and another valence electron to form what's called a double bond to a carbon and a hydrogen. So now let's see, what do we got? 2, 4, 2, 6, because this is 2, this is 4, and this is 2. 2. It's just, okay, so just know this is not right. We've gotten rid of 1, so now we have this, and it's like this. That's still not right. This is what needs to be done. So now we have 6. This is not right because this would be 4, 6, 4, 6. That doesn't make it 8. Remember how we said the triple bond makes it 6 valence electrons? We use the second, the lone pair, the second individual valence electron behind the first one that we used to make the double bond to make a triple bond. So that gets rid of these valence electrons, these lone pairs on top. Therefore, now let's count it. 6, 8, 6, 8. That fulfills octet's rule. Now, my explanation towards the end, it was a little bit shaky because I myself am still trying to comprehend this at an expertise level. But that's how you do it. That's how you get by, and this fulfills octet's rule. Thank you.